So this is still section 10.2, operations of matrices. We are on example number 6. Example number 6, you'll see, looks a lot like example number 5. It's asking for the same things. Take matrix A and B, multiply them together. Then switch the order. Take matrix B times A. Then take A squared, which just means you're taking matrix A times itself. But I have it as a second one because I wanted to show you that there are some strange things that can sometimes happen. So most of the time, the matrix multiplication is going to be like the previous examples that I've given you. But occasionally, you run into something weird, what I could perceive as being weird or just different. And so I want to make sure I show that to you. So on this one, find A times B. So A is 3, 2, 1. And B is 2, 3, 0. And the first thing I have to do is check. This is AB. Good form would have you writing AB equals this. I apparently don't have good form. But anyway, this is 1 row and 3 columns. It's a 1 by 3. This has 3 rows and only 1 column. It's a 3 by 1. So the first thing I have to determine is this even possible? So I look at these dimensions. The number of columns of this matrix matches up with the number of rows of that matrix. So it is possible. The remaining dimensions, 1 by 1, tells me what the dimensions of my answer is going to be. It's going to be a 1 by 1, which means it has 1 element. That's it. Okay? That's because I only have 1 row to take times 1 column. Because we always take rows times columns. So you're taking first element times first element. 3 times 2 is 6. 2 times 3 for the second element, 6. 1 times 0 for the third element, 0. Add that all up, I get 12. So I took a 1 by 3 times a 3 by 1, and I get a 1 by 1 for an answer. It's only one single value of 12. Does that not seem a little strange? Maybe not. Looks strange to me. All right, so then the second one, B times A. Same 2 matrices, but I switched the order around. So now I'm taking 2, 3, 0, and multiplying it by 3, 2, 1. Again, the first thing I have to do after writing them down is determine whether this is even possible. Again, this has 3 rows and 1 column. This has 1 row and 3 columns. Therefore, it is possible because the inner dimensions are the same. But notice, now, the outer dimensions that are left over for my answer is a 3 by 3. So that means I have 3 rows and 3 columns for my answer. I only had 6 total elements to begin with, but now I'm going to have 9 elements in my answer. This is the other part that's strange. Like over here, I only had 1 row and 1 column, so I had 3 products to do to add together. This time, as I do this, my first row only has 1 element in it. So I have my first row times my first column. 2 times 3, first element times first element is 6. Add all those up. There's only one number to add up. There's nothing to add up. I get 6. So then I take that same row times the second column. 2 times 2 is 4. Add those up. Well, it's just 4. 2 times 1 is 2. So that gives me my first row. Then I go to the second row. My second row is only a 3. So I'm going to take that 3 times each and every column. So 3 times 3 is 9. 3 times 2 is 6. 3 times 1 is 3. And so forth. All right. So then I go to the last one. I've got the 0. Multiply it by all 3 of these, and I get a bunch of zeros. So it's really, really strange. No, this isn't a system of equations. So it's not, I know you're used to when you see that, but it just happens that that last row is all zeros, all right? Just like the top row could have been all 6s or all 9s or something like that. So it's a strange answer. 6 elements, I end up with 9 total elements, but it's the way the matrix multiplication works. Same thing with this one. I had 6 elements and it went down to 1 element. Then you get the third one, which is the a squared. So to do a squared means a times a. So I would be taking 3, 2, 1 times 3, 2, 1. This is a 1 by 3, and this is a 1 by 3. The inner dimensions are not the same, so this one is not possible.